Here's a video key for your pedigree lab / practice. I do want you to complete this first before doing your study guide. The study guide might seem or feel overwhelming, but if you do this piece first, then the study guide should come along a lot easier for you. So I'm going to rotate my camera and really point out to you that you should do the reading. Okay, you can't work out pedigree problems without paying attention to the reading. And I prefer this activity because it does kind of spell things out for you in a very systematic way that will give you practice with how to do pedigrees. And then if you pay attention to the key, I've highlighted some important information in the reading that you will want to pay attention to, because you may be asked somewhere in your future what a pedigree is and what you can use them for. So a pedigree is a diagram that shows the occurrence and appearance or phenotype of a particular genetic trait from one generation to the next in a specific family. And there's different symbols and stuff you need to learn how to use. So in our example, in the previous video, I said males are noted as squares. Females are noted as circles. If there is a union, and in this one it calls it a marriage line, there's a union between two people, they draw a line there, and then any resulting offspring comes from that marriage line, and then you stretch out the line and you list the children in birth order. Generations are noted by Roman numerals, and individuals are noted by numbers. So I could identify this person as 1-1, or I can identify this person as 2-1. So representing generation 1, first person, generation 2, first person. So make sure you keep that in mind. So we're looking at free or attached earlobes. Free earlobes in this scenario are, well, not they are a dominant trait in our human population, and attached earlobes are a recessive trait, meaning I'm going to have to inherit 2 recessive alleles in order to have that recessive trait displayed. This particular lab doesn't go left-right, it runs down in columns. So make sure you pay along with that, because when we get to the 3rd page, these questions actually relate to that diagram, and some kids can get confused. They'll think it's that diagram. It's over here. We don't use that diagram until later, but I'll make sure to point that out to you. So our first diagram, we have an extension off our original pedigree. So then our generation 3 is the new addition, but then we renumber our generation 2 to include the inclusion of the son-in-law. And this one just gives you practice of naming the people by appropriate numbers. So it asks, what person is the son-in-law? That's this person. We identify him as generation 2, person 1. He's married to generation 2, person 2, and their child, as with a circle, is indicated as female. Now, what we can use pedigrees for that is helpful is it allows us to predict the genotypes of individuals. If we know the genotypes of some of the family members, we can make predictions about other individuals. And there's 2 rules that you need to memorize. Rule number 1 is assign 2 recessive genes to any person on a pedigree whose symbol is shaded. If they are shaded, regardless of what we're examining, they're typically going to be homozygous recessive. So give them the 2 recessive genes. If a person is unshaded, then we're going to assign them at least 1 dominant gene. We don't know what their second allele is, but we know since they don't have the recessive disorder, we can give them 1 dominant trait. So as long as you use those 2 rules in any scenario, you're going to be fine no matter what pedigree practice problems or whatever questions are set forth for you. Those are the 2 basic rules that apply to pretty much all pedigrees. So we're now looking at this figure. We have a recessive male with a normal female. They have a recessive daughter, 2 normal males. And then the daughter married a normal male and had a normal child. And so when we're asked questions about this, it's going to basically ask, can these 2 parents have these 3 kids? And the answer is yes, if mom is going to be heterozygous. So in our Punnett square, she's noted here as heterozygous. Here's the dad. And you have a 50-50 chance of having free or attached earlobes. So yeah, we could have this pedigree because each time they made a kid, there was a 50% chance for each kid to have free or attached earlobes. Now, the second allele for the 2 boys they had are going to be little e's. And we're looking at these guys right up here. They can only get these little e's from their dad. So they have, we know, like I said, we can make predictions. We know they got them from their dad. You get one copy from each parent. Mom made sure they were normal. Dad made sure they were carriers or heterozygous. If we look at this scenario, we have a normal female, but since mom's recessive, she gave that daughter her little e, making her heterozygous. Dad gave her the big E. And that's kind of how we can start using pedigrees to see where those genes are actually moving in a family. I'm going to lay these side by side because, again, these questions play off this pedigree. Could this child, could the child 2-3 or 2-4 be big E, big E? Could these brothers be homozygous dominant? And no, they can't because dad's homozygous recessive. He gave them a little E. So there's no way they could be heterozygous, homozygous dominant. That's just not going to happen. Now, then they have some practice problems. Could a person who's homozygous dominant marry someone who's homozygous recessive, have children with free earlobes? Well, yeah, that's the dominant trait. All the kids would have free earlobes. Heterozygous, same question. Could they have children with free earlobes? Well, yeah, it's a 50-50 chance. It's just the way it plays out with the probability. So, I mean, it's a dominant trait either way. Now, because that's an option, we're trying to figure out basically what his second allele was. Is he homozygous dominant? Is he heterozygous? Because either way, we're going to get that. Because it's an either way, we're going to write down either way. We don't know what his second allele is. We know what hers is because she got the little E from mom. She got the big E from dad. But we don't know what dad's second allele is. So to determine that, they would have to have more kids. We would have to wait and see, do we get a kid that has recessive trait for attached earlobes? If they have 6 kids and all the kids have dominant ears, it's probably safe to say he's homozygous dominant. But that's what question 8 is trying to figure out for you, is like, how can we determine their second allele? And if both work, you really can't until they have a larger family. So you'll note them as either or on a pedigree. Then they give you a scenario where we have a mom and dad that had a recessive offspring, and it asks you to pick which Punnett square could represent that pedigree. And it's B, because B is the only one that gives us recessive offspring. Everyone else would have a dominant allele present. And that's what we put in our explanation. Then in the analysis, it asks you to try to draw your own and label it. So we have our dad and mom with their marriage line. We have the children line coming off of that. And it said the 2 oldest children are boys. So I've drawn squares. The 2 youngest are girls. And then using the pedigree, indicate that generation 2, person 2, has attached earlobes. And so I shaded in that box. Okay. So at any point you need to go back and rewind this and see where you need help with, but make sure you got this pretty solid before you move on to your study guide pedigree packet. And if you need, again, let me know if you have any questions or if you need help.